In the first video on exponential functions, we're going to look at the function y is equal to 2 to the power of x being the exponent, hence the word exponential functions. You may have heard about exponential functions with coronavirus growth. It grows exponentially, and we're going to look at graphs that are in this shape here, growing quite quickly like this, or reducing quite quickly, could start high and could reduce quite quickly and level off like this. So these are the shapes of my exponential graphs. So let's look at y is equal to 2 to the power of x, and let's give some values to this. But let's start with 0. Let's say x is equal to 0. So we'll create a little table here just to start these. If x is equal to 0, 1, 2, 3, and 4, what values am I going to get for y? Create your table real quick. You don't have to draw the lines in between, and you'll see a pattern emerge here really quickly. 2 to the power of 0, anything to the power of 0 is equal to 1. So I actually only need one column here. I don't need the third column. I have my answer here. I say 2 to the power of x is y. So I have my x and my y. 2 to the power of 1 is equal to 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. What's happening? They're doubling each time. 2 to the power of 4 is 16. So let's graph this function. When x is equal to 0, 2 to the power of x is equal to 1. Let's call 1 this value here. And then the first line will be 2. 4, 6, 8, 10, 12, 14, 16. That's how high I need to go when x is equal to 1. So I can spread it out here. I can say 1, 2, 3, 4. And I do need to do the 0. Otherwise the graph would stop at this point here when x is equal to 1, 2, 3, 4. When x is equal to 1, y is equal to 2. When x is equal to 2, y is equal to 4. When x is equal to 3, y is equal to 8. You can see now it's starting to get steeper. And when x is equal to 4, y is equal to 16. So the first look at an exponential curve. At junior cert, you just deal with 2 to the power of x, or 3 times 2 to the power of x. Or it could be written as 3 times 2 to the power of x. So when we go on to deal with these with coronavirus growths, we're talking about y is equal to ae to the power of bt. That's where these are going, but this is just an introduction at junior cert. Go through as many of these videos if you want to get to the y is equal to ae to the power of bt. But for junior cert, just a basic introduction. Now, what's happening as we go left here? What happens when x is equal to minus 1? Well, let me just change these values. So when x is equal to minus 1, 2 to the power of minus 1 is 1 over 2 to the power of 1. So a half, 0.5. When x is equal to minus 2, we get 2 to the power of minus 2, which is 1 over 2 to the power of 2, which is 1 over 4, which is 0.25. 0.25. And you can see it's going to half each time, 0.125. And then 0.0625, 0.0625, and 0.03125, and so on. So you can see here, this line here, as it comes along here, is getting closer and closer and closer to that x-axis, and it gets very, very difficult to draw it without touching it off the x-axis. But to introduce a new word today, a line that veers towards another line but doesn't touch off it is called an asymptote. So the x-axis here is the asymptote, the line that it's veering towards. So it's never going to hit the x-axis, but it's going to get so small that we can say that it does tend towards 0. We're going to see language like that as we move forward. So this is the graph of y is equal to 2 to the power of x. You wouldn't be asked to sketch it between 1 and 5 because the jump is so great. We'd need a graph that's too big. So sketch this in your copies, the graph y is equal to 2 to the power of x, exponential functions, and in the next video we'll go and look at y is equal to 3 to the power of x.